All right, let's look at B now. We're going to look at example B, and you can see we have a right angle triangle again. And just to reiterate, just to state it again, we can only use these trig ratios on right angle triangles. And so my triangle XYZ is a right angle triangle because this angle right here is a right angle. Okay, so perfect. So we can use our sine, cos, and tan. So ka toa. Are you remembering that already, even though we've only just started? I hope so. Okay, and we need to find the side length that we don't know. We don't know this side right here. Why? We are unsure what that side is. We have this side length here, 13. That's the side across from Z, so it's lowercase z. Trust me, that's a lowercase. The side across from X would be lowercase x. Trust me, that's a lowercase. What is the side across from X called? Just out of curiosity. What is that side across from X? Well, it's the hypotenuse. Okay? It's the longest side of the triangle. It's opposite the right angle. So we don't know why. We know Z, we know this side length right here, and we know the angle of Y is 73 degrees. So using SOHCAHTOA, we have to decide which one we're going to use. Are we going to use sine, which is the opposite over the hypotenuse? Well, look at my angle that I know. The side across, that's what I'm looking for. That's the opposite side to my angle. So that's positive for sine. And then are we using the hypotenuse as well? Well, no, we actually don't have the hypotenuse. We have the side adjacent to 73. It's the side beside the angle there. It's adjacent. So sine isn't going to work. Cosine, the adjacent over the hypotenuse. Well, we have the adjacent side, but we're not looking for the hypotenuse. We're actually looking for y. We're looking for the opposite. So cos isn't going to work. Guess what? We have to use tan because tan deals with the opposite and the adjacent side. So let's write out the ratio. The tan of my angle, 73 degrees, that's the angle I'm using, is going to be the opposite, according to TOA, it's the opposite, so it's y divided by the adjacent, which is 13. And so again, I've set up a proportion here, and we've done questions like this before, where tan of 73 is just a number. If I write it over 1, then I have a fraction on this side, here, and I have a fraction on this side here. And what I can do is I can cross multiply and divide. So let me just get a different color again. I'm going to start with 13. I'm going to multiply up and across. That will be my multiply. And then I'm going to divide by 1. So my process will be 13 times the tan of 73, all of that divided by 1. So if we do that in our calculator, 13 times the tan of 73 is a number then divided by 1. We should get 42.52 and change. Now, again, if you don't get that number, it's probably because you're punching it into your calculator wrong, or maybe you're not in degree mode. Degree mode. You have to be in degree mode to do trigonometry always. So you always have to do that. So if you can't figure out how to turn your calculator into degree mode, let me know. This is how you use these trig ratios to find side lengths. That's all we're going to learn today because it's a lot of information. I want to give you some examples to try. So let me know if you have any questions.